All right, in this lesson, we are going to talk about how to graph general rational functions. And so for these kinds of functions, you're going to start having quadratics in the numerator, in the denominator. And so you can't use transformations to find the asymptotes. We have to use a completely different method. And so starting with the horizontal asymptote, when you are trying to find the horizontal asymptote, you have to use some vocabulary from our polynomials unit. You have to remember that the degree of a polynomial is the highest exponent, and the coefficient is that number in front of that variable. Okay, and so, for example, the degree of this polynomial is 2, and the leading coefficient is 3. The degree of this polynomial is just 1 because there's not another number there, so there's an invisible 1. And the leading coefficient would also be 1 because you don't see the number there. In this third numerator, the degree would be 3 and the leading coefficient would be 1. Okay, and so as you're trying to find the horizontal asymptote, if the degree of the numerator is equal to the degree of the denominator, meaning they're the same, then you are going to divide the leading coefficients. Okay. If the numerator is smaller than the denominator, the degree of the numerator is smaller than the degree of the denominator, meaning it's bigger on bottom, then automatically your horizontal asymptote is y equals 0. And then if the degree of the numerator is bigger than the degree of the denominator, there is no horizontal asymptote. So let's look at 3 examples. And so the case of number 1, the degree of the numerator is 2. The degree of the denominator is also 2. And so this is an example where they are the same. And so when they are the same, we divide the leading coefficients. And so my leading coefficients are 3 and 1. And so the horizontal asymptote would be y equals 3 over 1, which is just 3. And so we would have a horizontal asymptote at y equals 3. In the case of number 2, we have a degree 1 in the numerator, and we have degree 2. And so this one is bigger on bottom. And so bigger on bottom, it's going to be y equals 0. And for the last example, we have a degree 3 on top, a degree 2 on bottom. And so it is bigger on top. And so there is no horizontal asymptote. And so there's a funny acronym that we use to help remember these cases. And the acronym is BOBO, Botten, Eats, DC. And so BOBO is for bigger on bottom. And then that last O is the y equals 0. So bigger on bottom 0, BOBO. And then Botten is bigger on top, none. And so B-O-T-N, Botten. If it's bigger on top, none. And Eats, DC, is exponents are the same divide coefficients. EATS-DC. So Bobo Botten eats DC. Okay, and so that's only for the horizontal asymptote. And so I like to remember that horizontal asymptote is abbreviated HA. And so like ha, use the funny acronym. And so whenever you're looking for the HA, the HA, use the funny acronym. Bobo Botten eats DC. For the vertical asymptote, we just set the denominator equal to 0. So vertical asymptote, denominator equals 0. That's where we have a domain restriction because it makes the fraction undefined, the function undefined. And so to find the vertical asymptote, I'm going to use d of x to represent denominator. And so our denominator is 2x minus 4. And so when I solve this, I would need to add 4 to both sides and then divide by 2. And so we get x equals 2 for the vertical asymptote. Remember, your vertical asymptotes are always x equals a number, whereas your horizontal asymptotes are y equals a number. They're horizontal lines, and vertical asymptotes are vertical lines. Okay, for number 2, we set the denominator equal to 0, and in this case, it's a quadratic. X squared minus 4 equals 0. And so here I like to factor. You could just add 4, but a lot of people mess that up. And so x squared minus 4 is a difference of squares. So x plus 2, x minus 2. And so our solutions end up being the opposite of those factors. And so we end up with 2 vertical asymptotes. If you have a degree 2 in the denominator, you're going to have 2 vertical asymptotes. Sometimes. We're going to see some weird cases later. And then next on number 3, setting the denominator equal to 0. We have another quadratic, so we're going to end up with possibly 2. But this factors to x plus 1, x plus 1. So we have a repeated factor. And so in this case, only x equals negative 1 would be our vertical asymptote. All right, and so the next thing we need, other than the horizontal and vertical asymptotes, are our intercepts. And so to find the x-intercept, you're looking for the x value that makes your function equal to 0. And so you set y equal to 0, or basically the entire function equal to 0. And so when that happens, you really just care when the numerator is 0. And so I'm going to use n of x for the numerator. Okay, and so when you set the denominator equal to 0, that's your vertical asymptote. When you set the numerator equal to 0, that's your x-intercept. Okay, and then for the y-intercept, we're looking for the y value when x is 0. So for this one, we just substitute x equals 0, and that's a little easier because you basically just ignore the x terms. Okay, and so let's practice on these 3 examples. Okay, so starting with the x-intercept, I think let's use purple for x-intercept. Okay, so for x-intercept, it's an ordered pair when y is 0. And so we just need to set the numerator equal to 0. I'm going to write that step. So numerator equals 0. In this case, 9 is the numerator. There's no x there. So if you don't have an x in the numerator, you don't have a solution. And so there is no x-intercept. So you could say none, or D and E for does not exist. And so let's go ahead and do the x-intercept for number 2. So for the x-intercept, we're looking for the x that makes y 0. So we set the numerator equal to 0. X plus 5 equals 0. So x equals negative 5. And so you want to write it as an ordered pair. You don't want it to look like a vertical asymptote. And so negative 5, 0. would be our x-intercept. And then for number 3, setting the numerator equal to 0, we get x plus 4 equals 0. So our x value ends up being -4. So -4, comma 0 would be our answer. For the y-intercept, we just plug in 0 for x. And so that's for the entire function. And so x is 0. And so our y value ends up being 9 over 2 times 0 minus 4, which is just 9 over -4. This is 0. And that can't be simplified, so we're going to write it as -9/4. Always put the negative on top of a fraction. Okay, and so you take the entire function and just put 0 for the x. Okay, here we've got an x here and an x here. And so our y-intercept, when x is 0, we end up with just this plus 5 on top and just this minus 4 on bottom. So that's -5/4. So 0, comma, -5/4. Again, make sure you write it as an ordered pair, not an equation. Otherwise, it looks like the horizontal asymptote. Okay, and then for number 3, if I plug in 0 for all the x's, oops. We end up with only a 4 on top, and this goes away, and a 1 is left on bottom. And so our y-coordinate just ends up being 4. So I call it killing the x's. Just kill all the x terms, and it leaves you with your y-intercept. So you just have to simplify what's left. All right, so now we're going to put all this together and put it on the graph. Okay, and so let's start by finding the asymptotes. And so I'm going to start with the horizontal asymptote. Okay, so the horizontal asymptote, that's HA, that's the funny acronym. And so we're looking at the degrees. So we have a degree 1 over a degree 2. And so it's bigger on bottom, so BOBO, so automatically y equals 0. For the vertical asymptote, that's where we set the denominator equal to 0. And so I like to factor everything in sight. And so our numerator is x minus 3. This denominator factors to x minus 5, x plus 1. So if you want, you could do that at the very beginning. That's probably a better strategy. And so our denominator is x minus 5, x plus 1. And so one of our vertical asymptotes is x equals 5. The other is -1. We have 2 vertical asymptotes. So as we write the equations of the asymptote, it's very important to include the y's and the x's. Otherwise, I don't know if it's vertical or horizontal. So 1 horizontal asymptote, 2 vertical. Okay, and so next, let's do our x-intercept, which is our numerator equal to 0. And so setting x minus 3, that's our numerator. And so x equals 3, and then we write it as an ordered pair. And then our y-intercept, we plug in 0 for all the x's. And so you can either use the factored form or the original form. And so in the original form, I would have a 0 minus 3 on top, and then a 0, 0, so just a 0 minus 5 on bottom. So that simplifies to -3 over -5, which is just positive 3/5. The negatives cancel. And so 0, comma, positive 3/5. And so let's start putting this on the graph and see what we're working with. And so we have a horizontal asymptote at y equals 0. need a thinner line. So there's our horizontal asymptote. And then we had two vertical asymptotes. One of them was at -1, x equals -1. The other was at x equals 5. Okay, and so those are the asymptotes. And then now for the x-intercept at 3, 0. And then a y-intercept at 3/5, which is kind of close to the halfway mark. Okay, and so something you may be noticing is that we are crossing the horizontal asymptote, which typically isn't allowed, but when we start working with these general rational functions, you can cross a horizontal asymptote in the middle. On the ends, it's the end behavior that we care about. We'll not cross it again. And so you could cross it somewhere in the center of a graph, but as long as in the end behavior, it doesn't cross. That's what creates the asymptotic behavior. All right, and so we really don't have a lot of information to be able to create the curves of this graph. And so sometimes we need to find some other points. And so that's why there's a line for other points. And so when you're picking other points, pick points really close to the asymptotes, and so your vertical asymptote always divides your graph. So I'm going to have a section over here, I'm going to have a section in between, and I'm going to have a section on the right. So I already have 2 points in the middle branch, and so I know that I'm going to go through this y-intercept. So it's safe to assume you have part of your function approaching this vertical asymptote going up, and then we go and we cross the horizontal asymptote, and then it probably is going down towards this asymptote in order to go through those 2 points. It's the ends that we don't know. And so some good test points to choose. One would be this point close to the asymptote, and then another would be here. So I'm going to plug in +6, since this is 5. And then I'm going to plug in -2. I always pick a point that's close to the asymptotes on each branch. And so if I plug in x equals -2, and for this I like to use the factored form. And so the factored form is x minus 3 over x minus 5 and x plus 1. So we're filling in the -2 in 3 places. And so the numerator, -2 minus 3 is -5. The denominator is -7 times -1, which would be -5 over +7. And so 1 point would be -2, -5/7. And so that point would be about here. And so now we can know that the function is going to approach the horizontal asymptote and approach the vertical asymptote. So we're going to do the same thing with this x equals 6. And so y equals x minus 3 over x minus 5, x plus 1, filling in the 6 in all 3 places. And so we end up with 3 over 1 times 7. This is 1, this is 7. And so that's 3/7. And so 6, 3/7 is our other point. Okay, and so we know it's positive, so it's going to land up here. And so our other branch is going to approach the red asymptote and approach the green asymptote. Okay, and so the last thing we're going to do is identify the domain, which you honestly don't need the graph. You just need to skip over any restrictions, which we know would come from the denominator. And so we're skipping over these two vertical asymptotes. We have every other point. We have everything to the left of the asymptote, everything in the middle of the asymptote, everything to the right. And so our domain is going from negative infinity until we get to -1, which is our first asymptote. So negative infinity to -1, then -1 to 5. So union -1 to 5, using parentheses because we don't equal the asymptotes. And then the last branch is going from that 5 to positive infinity. So it's skipping over two vertical asymptotes here. Okay, last example. First step is let's go ahead and factor everything. And so for the numerator, we have to figure out two numbers that multiply to a times c, which is -6, that add to 1. And so that would be +3 and -2. And so we're going to split the middle. Anytime your a value is a number other than 1, you have to do this method. So we're going to split the 1x into 3x minus 2x. And then we still have the -2. So we can factor out a 3x. And here we can factor out a -2. And so x plus 1 is one of the factors, 3x minus 2 is the other. So that's our numerator. And then our denominator factors to, we need two numbers that multiply to -8 but add to +2. So 4 and -2. And this time we can skip to our factors. Okay, so starting with the horizontal asymptote, remember that's the HA, the funny acronym, and it looks like here are exponents. I like to use the standard form to do that. Our exponents are 2 and 2, so exponents are the same. So each DC, we divide the coefficients. And so we have a 3 divided by a 1. Which is just 3. And so one of the asymptotes is horizontal, y equals 3. And we can go ahead and graph that. Yes, okay. And so then for the vertical asymptote, this is where we set the denominator equal to 0. So this is where you want to use the factored form, x plus 4 and x minus 2. And so in one case, x equals -4, the other, x equals +2. Okay, and so we can put those on the graph. X equals -4. X equals +2. And then let's do the x-intercept. That's where the numerator equals 0. And so our numerator has two factors. So we're going to have two x-intercepts. And so x plus 1 and 3x minus 2. And so in one case, we get -1, so -1, 0. The other case, we would get +2 over 3, so 2/3, 0. Okay, and so -1, and then +2/3. And then for our y-intercept, this is where we plug in 0 for all the x's. So this is where it might be easier to go to standard form because this term would be 0, this term would be 0, this term would be 0, this term would be 0. So we just have a -2 over a -8. So when x is 0, we have a negative 2 on top, a negative 8 on bottom, which simplifies to positive 1/4. So 0, 1/4. Okay, and so this graph, we know what's happening in the middle. We can see it's going up and then going back down. And so after we connect the points, it's going to follow the asymptotes. So it kind of makes this upside down U shape. We don't know what's happening in the right branch, and we don't know what's happening on the left side. So this is where we want to get 2 test points. And so pick points close to the asymptotes. And so picking x equals 3 would be a good idea. And picking x equals negative 5 would be a good idea. Okay, and you really just need to know if it's above or below the green so that we know where to draw it. If it's above 3, we would know it's up here. If it's below, we'll know it's down here, which it's probably not down here because we don't have any more x-intercepts. And so if you were to just guess, I would guess up here. Same with the other branch. We would guess up here because I don't have any more x-intercepts. And so if it were down here, I would have another x-intercept. And so just plugging those values in to be safe, I'm plugging in x equals 3 and x equals negative 5. And I'm going to use the factored form. We had 2 factors on top, 2 factors on bottom. And so the factors on top were x plus 1, so 3 plus 1, and then 3x minus 2, so that would be 9 minus 2. And then x plus 4 on bottom, and then x minus 2. Putting in 3 for all 4 x's. And so that simplifies to 4 times 7 over 7 times 1, which the 7's would cancel, leaving us with just a 4. And so 3 comma 4 is one of our other points, which is what we expected. So our right side is going up towards the asymptote, down towards this asymptote. And then plugging in negative 5, you have 4 factors, 2 on top, 2 on bottom. And so for our first factor, we would have negative 5 plus the 1, which would give us negative 4. And then we would have negative 15 minus 2, which is negative 17. And then on bottom, we would have negative 5 plus 4, which is negative 1. And then for our last factor, negative 5 minus 2 is negative 7. Okay, and so on top, we would have a negative times negative, which would be a positive number. Gosh, it's a big number. 40 plus 28, so 68 over 7. And then 7 times 9 is 63. And so this would be 9 and 5/7. So pretty close to 10. So this point would be way up here. But since it's above the asymptote, we know the branch is up in this quadrant. Okay, and so we have the point negative 5, 9, and 5/7. All right, and so for our domain, just like the last example, we just need to skip over our vertical asymptotes. So we're going to have negative infinity until negative 4, negative 4 to positive 2, and then positive 2 to infinity. So negative infinity to -4, pick back up at -4, go to 2, pick back up at 2, and go to infinity. And so that's the domain for each of our 3 branches.